Good morning, everybody. Today we have to start with a new chapter, which is a chapter 14 about unsaturated hydrocarbons like alkenes. The objectives that we are going to explain them today about the definition of an alkene, the general molecular formula and the occurrence of an alkene, about the way to write the systematic name of a linear and a branched chain alkene, and the way to write the condensed structural isomers of alkenes. Let's start first by defining an alkene. An alkene is an unsaturated hydrocarbon, which is characterized by the presence of the double covalent bond between two carbon atoms and their carbon chain. They have a general molecular formula CnH2n, where n represents the number of carbon atoms. Don't forget that cycloalkanes also have the same general molecular formula, which is CnH2n, where n is greater than or equal to 3, but unlike alkenes, cycloalkanes are saturated hydrocarbons. Alkenes are rare in nature. They are found in some plants and they are produced by petrochemical industry, which is an industry used to produce organic intermediate products such as natural gas, plastic, rubber, etc. Let's start with the rules now to give the systematic name of an alkene. First, we will start with a straight chain alkene. To give the name of an alkene, simply it's derived from the name of its corresponding alkane that has the same number of carbon atoms in the carbon chain, just by replacing the suffix "ane" by "ene. Take the following two examples. The first example, the carbon chain is made up from two carbon atoms. Instead of writing ethane in the case of an alkane, now you should write it ethene in the case of an alkene. In the second example, the carbon chain is made up from three carbon atoms. So instead of writing propane in the case of an alkane, now you should write it propene in the case of an alkene due to the presence of the double covalent bond. The second rule is related to the chain that contains more than 3 carbon atoms for n greater than 3. In this case, you should localize the position of the functional group which is here represented by the double covalent bond. The way to represent the functional group in the name of an alkene, you should enumerate this chain in such a way that the carbon atom holding the functional group, the double covalent bond, must receive the lowest number. So if we take the first example, if you start here from the left, then this carbon holding the double covalent bond will be the first carbon atom. While if we start from the right, then let's enumerate it 1, 2, 3. Then the carbon holding the double covalent bond will be the third carbon atom. So you should start from the left, since the carbon holding the double covalent bond must receive the lowest number. So what's the way to write the name here? You should start by writing the position of the double covalent bond, which is here at carbon number 1. So we write it 1-butene. Butene, since the main chain is made up from 4 carbon atoms. In the second case, also here, if you start by enumerating the chain from the left, then the carbon atom holding the double covalent bond will be the second carbon. So now the name of this alkene is 2-butene, since the double covalent bond is attached to the second carbon atom. The third rule is related to an alkene with a branched carbon chain. The first step to write the systematic name of a branched chain alkene is to take a main chain in the given alkene. The main chain in the given alkene is the longest carbon chain containing the double covalent bond. The second step is that you have to enumerate this chain in such a way that the functional carbon, which is the carbon that is making the double covalent bond, must receive the lowest number, and in the third step you can indicate the location of the substituent groups or alkyl groups by the number of the carbon atom to which they are attached. Let's take the first example. In this example, the main chain is made up from 4 carbon atoms containing the double covalent bond. If you enumerate this chain from the left as represented, then the double covalent bond is attached to carbon number 2, and the branch is located at carbon number 2. So the way to write its name is 2-methyl. Methyl, since the alkyl group here is CH3, 2-methyl, since this alkyl group CH3 is attached to carbon number 2. So we write 2-methyl, 2-butene. 2-butene, since the double covalent bond is attached to the functional carbon number 2, and butene, since the main chain is made up from 4 carbon atoms. In the second example, also here the main chain containing the double covalent bond is made up from 4 carbon atoms. If we enumerate the chain from the left, then the functional carbon that's making the double covalent bond will be the first carbon atom. While if we start from the right, then 1, 2, 3. So the functional carbon will receive the third number. So we should start from the left. If you start by enumerating the chain from the left, then the first branch, which is methyl here, CH3, will be located at carbon number 3. So its name is a 3-methyl. And 1-butene, since the double covalent bond is attached to carbon number 1. So 1-butene, since the main chain is made up from 4 carbon atoms. In the third example, the main chain containing the double covalent bond is made up from 5 carbon atoms. Here, if we start by enumerating the chain from the left, then the functional carbon atom that's making the double covalent bond will receive number 2, while if we start from the right, then the functional carbon atom will receive number 3. So here we should start from the left. So if you start from the left, the branch CH3, this methyl group, will be attached to carbon number 4, then it's called 4-methyl. And since the double covalent bond is attached to the functional carbon number 2, then the main chain is called 2-pentene. Pentene, since the main chain is made up from 5 carbon atoms. In the last example, the main chain containing the double covalent bond is made up from 5 carbon atoms. Here, if you start by enumerating the chain from the right, then the functional carbon atom that's making the double covalent bond will receive number 2, while if you start from the left, the functional carbon atom will receive number 3. So we should take it from the right. By enumerating the chain from the right, then the 2 alkyl groups, the 2 methyl groups, will be located at carbon number 4. So they are called 4,4-dimethyl. So we should write number 4 2 times, since we have 2 methyl groups at carbon number 4, and dimethyl, since we have 2 methyl groups. Now we should mention the name of the main chain. 2-pentene, 2 since the double covalent bond is attached to the functional carbon number 2, and pentene, since the main chain is made up from 5 carbon atoms.